Okay, so first of all, I will figure out where this angle is. Okay, so 12, and then the next would be like that. 24 would be a whole circle. So then what?
Plus another
12, 24. Should we go by 6, 12, 18, 24? Should we do that? Right?
Okay.
Half of 12 is 6. A full pi is 12.
Yeah.
1.5 pies is 18. 2's 24. So then the next would be 30. Oh, I don't want to go that far.
Oh, one away.
So we're
A little one.
we're like that. So now, because this is a bottom of 12, it's a 15 or 75. So what is this? Is it 15 away or 75 away?
75.
75 degrees away from the x-axis. Which means I'm going to treat 75 as a 45 plus 30. So I'm going to do the sine of 45 plus 30.
And you did sine. Okay.
I did sine because the question said sine. That's why. Okay, now I'm to my formula sheet on this side, and I'm finding the sine of a plus b. So everyone found a formula to use. Sine 45 cos 30 plus cos 45 sine 30. So that was a copy from the formula sheet. Good so far? Now I'm going to give myself 4 brackets to fill in trig values. And then, do you remember my little cheat method? What do I fill in first? 45.
2.
Because no matter what, this is easy at 45, the sine and the cos are both root 2 over 2, root 2 over 2. At 30 degrees, we got the cos, which is the x value. So root 3 over 2. And at sine 30, I'm trying to get the y value, 1/2. And there's one thing you need to do at the very, very end with this. Check your Astica situation. We're in this quadrant. So do we need to negate our sine number? No. So we're done. That would be it. So the only things I really added to that question were if it was in an Astica negative quadrant, you bracket negative. And the other thing would be if I'm doing a secant or a cosecant, you do the same process and then at the very end, flip them, right? Okay, the next little thing we're going to learn today, this is back to your notes paper, is just working opposite of that. Just a little bit backwards. So, we're working with the formulas we just worked with. So before we were here and then we expanded it, right? This is in the notes?
Yeah. Just the next page.
The notes. So we've already, so sine of 45 plus 30 or whatever, we expanded it. Now we're going to take the expansion and go back. Okay, so I expanded something. So this formula says cos, cos plus sine, sine. Can you find me an expanded formula that matches cos, cos plus sine, sine?
Cos A minus B.
Good. Everybody found cos A minus B? So then I'm going to go, what is the cos of A minus B? Okay, now, guess what I'm going to do? What is 80 minus 50? Cos 30. And then, what am I grabbing? My unit circle. And at 30 degrees, the cos value is root 3 over 2. And that's my answer. So I'm just kind of adding one thing to what we already know.
Is this like, you said the last test was medium, is this hard or medium or easy?
This is medium because this stuff seems easy, but there's one part that's hard. So then if I put easy and hard together, it makes medium.
Yeah, I agree.
That's how math works. Okay, sine cos minus cos sine. Can you find me a formula match? Sine cos minus cos sine. Are we all finding it? I did a sine of A minus B, right? Cole, did you find it its match?
Yeah.
Sine A minus B. So sine of A minus B is what it matched to. Then 73 minus 13 would be 60. And that means I go to my unit circle and I go to 60. And what is the y value? Sine is the y. So it's root 3 over 2.
Now we got fraction.
What's that?
Fraction.
That's it. Just the trig values.
That's the next.
Oh, the next one is fractions. Do fractions scare you? We're going to do a fraction.
Yeah, why can't we just have nice whole numbers?
Like 73 and 13.
Yeah.
Okay, find me a formula. Cos cos plus sine sine. Cos cos plus cos cos. Cos cos plus sine sine. Did you find me something? Cos cos plus sine sine. So that is the cos of A minus B. Cos of A minus B. Are you scared yet, or it's okay as a fraction? This is still okay? Okay. Can you do 11 subtract 7 on the top then? 4 pi over 24. Now, on the test, this is where I see people get stuck. Because they're like, 4 pi over 24, that's not on my unit circle. What? I need to reduce that fraction. And then things will look familiar. What can you divide the top and bottom both by? You can by 2, but what more can you divide it by? 4. So I'm going to divide the top and bottom by 4, which turns into pi over 6. Then do things look familiar? So I go to pi over 6 and grab the cos value, which is the x. Apparently I have a theme with my answers, because it is also root 3 over 2.
Can you keep that theme for the test so we can just
I feel like if I had this as the test, that would mess up my mind, because I'd be like, these all can't be the same answer, and then it would.
see if we know
Oh,
going.
God, the opposite of the pattern.
Okay, tan. So which tan is this? Is Is this the tan of A plus B or tan of A minus B? Which one? A plus?
Yeah,
That's the formula it matches with? A plus B? Okay, so tan of A plus B. The tan of A plus B it matches with? Okay, we're going to do the same thing as we just did. So 11 plus 17. Wait, why did I write 17? Hopefully no one else did that. That makes more sense. 11 plus 7. 18 pi over 24. That probably doesn't look familiar again. So what should I do with 18 and 24? Is 2 the most? I think there's a bigger number to divide by.
3. What? 6.
12? No.
6. 6 is the biggest. I can divide that by 6, yeah. So tan of 3 pi over 4. Okay, now I got a unit circle number. So 3 pi over 4. Ooh, this is a fast one. We can divide this quickly.
1.
Negative 1. Those numbers will divide. Everybody sees it? This divided by this is what you're doing. Boom, negative 1. There, have a different answer then.
Yeah,
I'll still go.
we're barely gonna ski.
Yeah, I know.
We're just gonna have like
Okay, we are going to do a little fun here. We're going to do a proof. We're going to prove
I'm just like making it like a.
this formula down here using the addition formula. Okay, so sine of 2a can be the same as sine of a plus a. Does that make sense to you?
Yeah.
Right? I replaced 2a with a plus a. Now, can you use your formula, this one, and write the expanded version? Obviously, every time you see a b, it's an a. Does that make sense? So sine of the first angle, cos of the second angle. So sine of the first times cos of the second plus cos of the first sine of the second.
But
Everything is just a's though, right? Because the first angle was a and the second angle was a. I could have r or s or I can have anything in there. You know what I mean? It's not just a's and b's, but.
it's just like 2 15s or something. Right?
And then this and this are the same term, so it would make 2 of those. And we showed that that's why it happens.
So we just kind of like expand it and loop back to y.
Yep.
Oh gosh.
Okay.
This
Oh,
is Susan.
I'm going to do one with you here. On page 3. Okay, so this says 2 times the sine of an angle, cos of an angle. So what is that matching on my sheet with? Looks like, bless you. It looks like this one, right? 2 sine of an angle, cos of an angle. So it is sine of twice the angle. That's what it matches to.
Okay.
Okay, I found the matching formula. Now, I need you to simplify that angle for me, as in it would reduce. What happens to this when you times it? What happens here?
I don't think it's stupid.
2/16?
That's not what it's saying.
But I don't think that
I
is
don't
it.
think it's right.
Sometimes it helps to throw this over top of 1 so you can see things better, maybe.
2 pi over 8.
Because it's not in brackets. Then it would be that.
But 2 pi over 8.
2 pi over 8, but it reduces.
Oh, what quarter? Or just pi over
Power
4.
4. It just reduces like magic.
Right?
It doesn't always change.
Please don't times the top and bottom by 2. You don't want to turn anything into 16 on the bottom, right? Because it's just doubling the top.
Stupid.
Okay, now can you find me something that matches on your unit circle? So you go to pi over 4,
Or 2 over 2.
and at pi over 4, you're looking for the sign. So you're looking at the y